Here's a thought experiment you're not supposed to ask in cosmology. But if it's right, it explains why every model of the universe breaks when time equals zero. What if the universe didn't begin with a bang at all? What if it began in a state so simple that math itself didn't exist yet? Today we're going to walk into that forbidden starting point, a place I call zero state. What if math doesn't describe the universe? What if math is the universe? And if that's true, then the biggest problem in cosmology suddenly snaps into focus. When time equals zero, it doesn't produce infinities, it produces an error. Time equaling zero creates infinities because we treat math as if it existed before the universe. And that assumption breaks the system. If mathematics is the fabric of reality, then math cannot pre exist the universe. And if math wasn't there at the beginning, then neither were any of the rules we normally assume. So let's step back and start at the real beginning. Not the Big Bang, but the structure beneath it. Most stories about the universe start with absurd complexity: infinite temperature, infinite curvature, infinite density, laws already in place, fields already operating, time already ticking. Nothing in nature begins that way. No system starts on top of the mountain. Systems begin at minimum complexity, not maximum. So why would the universe? Why assume chaos is the starting point when every other system we know starts with simplicity? If the universe is built out of mathematics, then its foundation should reflect mathematics' simplest concept: zero. Not nothingness, not empty space, not darkness. Zero is something more precise. Zero is existence with no distinctions: no shape, no time, no distance, no direction, no rules, no structure, no differences. A state with no differences because difference hasn't been defined yet. State where information is impossible because information requires difference. This is the zero state. Not non existence, not vacuum, but perfect symmetry. A universe in the zero state cannot change. Change requires a distinction, a before and after, a direction, a contrast, a cause. Zero has none of these. Zero cannot produce motion, heat, or expansion. Zero does not wait. Waiting implies time. It is stable for one reason: it has no structure to destabilize. Zero is the blank substrate beneath mathematics and beneath physics. Everything else must come later. John Archibald Wheeler, one of the most influential physicists of the 20th century, suggested every physical it arises from bits of information. Particles, forces, space-time, these aren't fundamental. The binary distinctions underneath them are. But Wheeler never took the final step. He never asked, where does the first bit come from? How does the first distinction appear in a world with no distinctions? He reached the doorway but never crossed it. The answer lives in zero. The universe begins the moment zero is no longer perfectly symmetric. Not with an explosion, not with expanding space, not with light or heat, but with a single difference: a crack in uniformity, a distinction, the tiniest possible deviation from perfect symmetry. Call it the first bit flip if you like. Zero flips to one. With only two possible states, 0 and 1, the system now contains information. And the moment you have information, you have structure. The moment that you have structure, you have relationships. And the moment relationships exist, physics can begin. With 0 and 1 available, The system can now form sequences. These aren't numbers, they're patterns. Patterns imply order, order implies before and after implies time. Different patterns mean contrast, and contrast is the seed of energy. How patterns relate, long versus short, connected versus separate, is the seed of space. The ability for patterns to grow, branch, and interact is the beginning of causality. Before there are particles, equations, or forces, the universe must first have a way to tell things apart. That begins with the first distinction. From inside the system, the sudden appearance of distinctions everywhere at once looks like an expansion. What really happened was simpler. Perfect symmetry broke and structure appeared everywhere simultaneously. Patterns formed, contrasts emerged, space unfolded out of information itself. Wheeler said it from bit. But the fuller picture is simpler. Before the first bit, there was zero. From zero comes distinction. From distinction comes everything. If the universe is math, it must begin the way mathematics begins, with zero. Zero doesn't smuggle in rules. Zero doesn't hide infinities. Zero doesn't require fine tuning. Zero doesn't assume complexity. Zero is the only beginning that requires nothing beyond itself. Everything else, space, energy, time, life, is what happens when the simplest possible state creates the simplest possible difference. The universe began with a bit flip. Once zero breaks, everything else is inevitable. Reality is just the aftermath of the first distinction. And this isn't just physics. Distinctions show up everywhere, including in us. And maybe consciousness is just another distinction, the one where the universe learns to separate self from everything else. If the universe began with perfect symmetry, a zero state with no distinctions, then several major puzzles in physics become simple consequences rather than mysteries. Number one, the singularity problem. General relativity predicts an impossible infinity at time equal to zero. The symmetry break replaces the singularity with a transition. No infinities, just structure emerging. Number two, laws don't pre exist the universe. Most models assume quantum fields, inflation, or even math existed beforehand. But in this conceptual model, the rules don't pre exist the universe, they emerge with the first distinctions. No preloaded physics required. Number three, quantum versus relativity. Discrete distinctions give rise to quantum behavior. Continuous geometry gives rise to spacetime curvature. Both arise from one boundary event, two domains, one origin. Number four, the arrow of time. Physics doesn't build time's direction into its equations. The laws work the same forward and backward. But if the universe begins with a symmetry break, then the arrow of time can be seen as a steady accumulation of distinctions. The universe moves away from zero, and that movement feels like time. Number five, fine tuning. If early structures come from a symmetry break, physical constants may be geometric consequences, not lucky coincidences. Number six, something from nothing. Zero isn't nothing, it's the simplest possible state. No distinctions. The universe begins when zero produces one difference, not magic, not creation from nothing, just the minimal step from symmetry to structure. The zero state model isn't offered as truth, only as a cleaner starting point. A universe built from mathematics may begin the way mathematics begins, with zero. And everything since then is what happens when zero learns how to become something. The only question that remains is what caused the first bit flip? My answer? Nothing causes it. Perfect symmetry contains no mechanism that can hold it indefinitely. The bit flip is what happens when the simplest possible system can no longer remain perfectly symmetric. This is not a cop out. It is the same logic used in spontaneous emission, vacuum decay, Higgs field symmetry breaking, inflationary instability, and quantum tunneling. These are all uncaused transitions, not forbidden by physics, not supernatural, simply inevitable.